Algebra 2, we're at 9.8a, and this is quadratic functions from a graph or 3 data points. We've got 16 previous videos for Chapter 9. If you become lost or confused, just click this description to watch them. We can find a quadratic function that fits a curve if we know 3 data points. We substitute the x and y values into y equals ax squared plus bx plus c to get our system of equations. Then we can use linear combinations, also called the elimination method, to slowly solve for each variable. And this will find our coefficients of the quadratic function. So we can find the quadratic function that fits this curve. We have 3 data points. We have a -2 for x and a 5 for y, which is right here. We have a -1 for x and a 5 for y, which is right here. And we have a 0, 1, which is right here. So now we just need to find the quadratic function that fits this curve. So we substitute these 3 data points into this function. I'm going to set it so it equals y. Y equals. So we've got 5 equals, we've got a -2, so we're going to put a -2 everywhere there's an x in this first one. So we have 5 equals a times a -2 squared plus b times -2 plus c. Then we're going to use the second set. We're going to have 5 equals, and then our x value is going to be a -1. So now it equals a times a -1 squared plus b times -1 plus c. And we can see here that this one equals 1, and all the x values are a 0. So we don't have any a and b values, do we? Because they're a 0. So 1 equals c, doesn't it? And we can simplify this. For our first equation, -2 times -2 is a +4. So now we have a 4a. And we've got a -2b plus that c. For our next one, we've got -1 times -1, which gives us +1a. And we've got a -1b plus our c. And we don't need to write the 1 in front of these, do we? We can have they could just be our buddy, the invisible one, can't they? We know 1 is c, all right? So now we can substitute 1 for c and have 2 remaining equations in our system. So we don't need to have a system of 3 equations. We know that c is equal to 1. We could just write these with the 1 for the c. Now we can solve our system. So I don't know if you remember this, because it was quite a while ago. It was from Chapter 4. It was videos 4.4a, b, c, and d. We're going to use linear combinations, also known as the elimination method, and we slowly eliminate the variables and solve for their values. So here's our first equation, okay? We've got 5 equals 4a minus 2b plus c, and we're going to get rid of that c value. So we're going to subtract 1 from each side of the equation and get 4a minus 2b equals 4. We're going to do the same thing for that second equation. We have a minus b plus 1 equals 5. If we add a -1 to each side of the equation, we get a minus b equals 4. So now the c is eliminated. Now we're just left with this first equation and this second equation. Now we can eliminate this b right here by multiplying this second equation by a -2 for every term. So we multiply the a, the b, and the 4 by a -2. And we just move our first equation down, and we get a -2a, and because we have a -2 times a -1b, we get a +2b minus 8. And that created a 0 pair here, didn't it? It's additive inverses, so this is gone. So now we just have 2a equals a -4. We can divide both sides of the equation by this coefficient 2, and we get that a is equal to -2. So now we have our first variable and our c, don't we? We have a and c. Now what we do is we take our equations, the ones where they equaled the 4, because we already got rid of the c because we know it equals 1. We take this equation and this equation again, and now we're going to eliminate a. And we can do it by multiplying the second equation by a -4, because that'll create a 0 pair here, won't it? We want to multiply it by something that's going to create an additive inverse. So we multiply every term of this second equation by a -4. And we get a -4a and because it's a negative and that's a negative, we get a positive 4b, and it's going to equal a negative 16. Now we add them together, and we get our additive inverses here, our 0 pair, so now the a is gone. We have negative 2b plus 4b, that's going to give us a positive 2b, and it's going to equal a negative 12. We divide each side of the equation by this 2 coefficient, and we get b is equal to negative 6. So now we know that a is negative 2, b is negative 6, and c is a 1. These are the coefficients for the quadratic function. So our quadratic function is the function of x equals negative 2, that's our a value, x squared minus 6, x plus 1. See? I'm going to have a link to that 4.4 videos that talk about doing this for the linear combinations and eliminating. That'll be in this description too, along with the other 16 videos that we've done for this chapter so far. We're almost done with this chapter. We only have 1 or 2 more videos left, and we'll be in chapter 10. So our next video is 9.8b, and we're going to do some word problems that involve quadratic functions. I'm going to add this video to the Algebra 2 playlist. Please hit the like button if this video made sense and it helped you in any way. And keep trying, keep going. We're getting through this, and I really believe in you. I'm really proud of you for watching these videos, and I think you can do this, okay? I'll see you next video. Bye.